Question 7 is about a step-down transformer. Okay, so with this step-down transformer, you've got the primary coil coming in with lots of turns. Okay, for example, that would be connected to the 240 volt supply in the UK and Thailand. Then you've got the iron core, and then on this side, you've got far fewer turns. For example, I think laptop chargers run off 15 volts. Okay, so because the number of turns is proportional to the voltage on each side, okay, if it's stepping down to a low voltage, that means that there's going to be less turns on the secondary. So the answer is B. Okay, so the equation here really is just the energy or the power into a transformer. Okay, we assume that the transformer is 100% efficient, and in reality they are pretty close to that. So the power into the transformer is equal to the power out of the transformer. That means that the voltage on the primary times by the current on the primary is going to be equal to the voltage on the secondary times by the current on the secondary. Then asks you to calculate the current in the secondary. So if you substitute into the equation above, you get this, and then there's some careful rearranging. And then work out the answer on a calculator, and you get 4.8. If you look at the answer given on the calculator, it says 4.79 blah 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 blah. Okay, but as you can see from the question, we only know this to two significant figures and this to two significant figures, so it's only appropriate to give our answer to two significant figures. If you gave to more significant figures than that, you wouldn't lose the mark there, but it's just good physics if you've given it to the right number of significant figures. Okay, if the charger becomes warm, that means that some of the electrical energy in is not going into electrical energy out. So there you can see that's the conservation of energy. The electrical energy in is equal to the electrical energy out, plus some is now being wasted as heat. If you remember, in part A they asked us to write down the equation, and what that equation assumed was that the transformer was 100% efficient. Because some energy is being wasted as heat, we now know that that isn't true. So because of that, either the voltage on the secondary coils or the current through the secondary coils must decrease.